In this video, we'll sketch the graph of f of x equals to 1 plus root of 2x plus 1, and also find the domain and the range. Okay, so we have f of x equals to 1 plus root of 2x plus 1. So to sketch this one, we should first know the general graph to use. And the general graph to use for this one is y equals to root of x, because the leading coefficient, or simply the coefficient outside there, is positive, even inside that's positive. But we won't just go direct here, there are some rows to follow. Okay, so we should check what's under the root there. You have 2x plus 1. The coefficient of x there can be positive or negative. Here it's positive. Then for you to proceed with sketching, ensure that the coefficient of x there is 1, so it should be 1. So meaning we should do something to this function. So f of x equals to 1 plus. So this is what you would do. We can actually factor out this 2. Just inside there, I'll say 2, then x plus 1 over 2. So that when we multiply, we get back to that 2 times x, that's 2x. 2 times 1 over 2, that's 1. Then we won't just end here. Remember these laws of indices. Or instead of saying indices, let's use radicals. If you have root of ab, this is equal to root of a multiplied by root of b, provided a and b are actually positive. So you can apply this one there. Say f of x equal to, so it's 1 plus root of 2 root of x plus 1 over 2. Okay, then from there you deal with this one first. So you sketch this part first. Okay, but before that, we'll start with the general function or the general graph. So this one, if you just know that it goes like this: y equals to root x, y equals to root x. Then from there you come to this x plus 1 over 2. So we know that when we apply this f of x plus a like that, so this is actually a horizontal translation of negative a, meaning that whatever you have there should be multiplied by negative 1, or simply equate what you have there to 0 and so for x. So meaning x there will be negative 1 over 2. So you have to draw a line x equals to negative 1 over 2 dotted like that. So this is x equal to negative 1 over 2. Then this will simply mean this point will shift to that point there. Then this is the graph we end up having. So this is now y equals to root of x plus 1 over 2. So it is just this one which has been sketched now. We have to also apply root 2 and also that positive 1. Okay, so there's this other row for stretch. So it's a stretch, we say a f of x like that. So if we have a f of x, so in this case, which one is the f of x? This one, representing that f of x. Then this a, that is the root 2. So if you have such a case, you multiply the y coordinates by a and leave the x coordinates unchanged. Okay, so this function, this one which has already been sketched, it has x and y coordinates. So multiply the y coordinates of this by a there, which is root 2, and leave the x coordinates unchanged. So we know it's easier to pick this point and that point. So picking this point there, we have x negative 1 over 2, y 0, okay? Then let's also pick this point. So picking this point, we know this is the y-axis, meaning x should be 0. So 0, comma, what's the value of y? So if we have 0 there, y will be what? Root of 1 over 2, so it will be root of 1 over 2, and we know this is what? 1 over root 2. So here we have 1 over root 2, like that. Okay, then let's apply this root 2. What did I say? We multiply the y coordinates by root 2. We leave the x coordinates unchanged. So what will be the new coordinates now? So this will change to what? So 0 multiplied by root 2, it is still 0. So this will remain like that. Then this will change to what? So 0, comma. So we say 1 over root 2 multiplied by root 2. It's 1. Okay. So these are the new coordinates we should have. So let's try to locate them. So negative 1 over 2 comma 0, it's simply there. Then 0 comma 1. 0 comma 1, it's somewhere on top there. Since this is 1 over root 2, 1 should be on top there. So the new graph now will be like that. So this is y equals to root 2, again root of what? X plus 1 over 2, like that. Okay, then there is that plus 1. We are not yet done. We have this plus 1. So how does this work? There's this row for f of x plus a, like that. Okay, so this is actually a vertical translation of a itself. So meaning we maintain the same number which is there. If it is negative, we maintain the same negative. So this is positive. So you draw a line, y equals to 1 if it's under the root. So have you seen how we are treating this which is outside the root, and that 1 over 2 which is under the root. Okay, so let's do that. So we should draw y equals to 1, and it's at this point. We do this. Okay, so this is y equals to 1, like that. Then how does this affect our graph? So remember I said this is our vertical translation, meaning the graph can move up or it can go down. So meaning this point will actually move up, so it will go to that point there. Okay, so initially we even want supposed to extend this so that we can have our graph going like that. So this is our final graph. As you can see, no wonder I've not used dotted line. Then we even have to label that this is actually our f of x equals to 1 plus root of 2x plus 1. That's it. If you want, you can even try to find the value of what y at this point. And from the look of things, if we say we have 0 there, automatically we have a 2. Yeah, root of 1 plus 1. So we have a 2 there. So this is the final graph. Then let's state the domain and range. So domain, whenever you hear domain, state the domain. They are simply talking about the interval for x values, or simply the x values. Okay, so you can write that in set builder notation. So for x values, let's take the starting point of our graph. This is the starting point, then it's going to the right, like that. Consider the final graph. Starting point going to the right, like this. So the starting point, what's the x value there? Negative 1 over 2. So here we say we have to state that x is a member of real numbers such that x, so it's going to the right, meaning x is greater than or equal to negative 1 over 2. Then range. So for range, so we should state y is a member of what real numbers such that, let's check. This is the starting point of our graph. What is the y value at this point? So the y value, as you can see, it's 1. This is where this graph y equals to 1 is passing. So y value 1. Okay. So for this one, we'll say y is greater than or equal to 1. Since even this one is part of the graph. That's it. So that's how we go about sketching that one using those transformation rules. Okay. So what you can do, you can try to practice, try to answer the same question using this method. So answer it according to how I've answered and see if you have gotten the concept. Otherwise, I have explained very well these concepts from the beginning. Just from the beginning, you can reach me out on WhatsApp. Yeah, so you can reach me out on WhatsApp for video lessons. I've explained everything from the beginning, the rules to use when sketching. Otherwise, you need a lot of practice. That's it for this lesson. Hope you have understood.